It's time for another amazing chemistry video with Mr. Stapleton! Proudly sponsored by Farming Nice Coffee.
Hi guys, welcome to the next video that I'm putting together for you. Hopefully you've been finding them informative and helpful. Today I'm going to go through different types of reactions and some of the common products. So I'm just going to start off with hopefully some interesting things for you. So first thing I'm going to do is an acid-base reaction. Okay? So acid-base reaction, alright, I'm going to always put the reactants up the top here, put the products down the bottom. Acid-base reaction always gives us two products. We get salt and water. Okay? So this is regardless of the acid or the base. Okay? What I want to focus on to begin with though is salt. Okay? Because some people get confused. When they think of salt, they just think of sodium chloride. So I'm actually going to talk about what a salt actually is. Okay? So a salt, okay, refers to anything that is made up of a cation, okay, normally which is a metal, okay, and an anion part. Okay, the anion part is what normally comes from your acid when you're doing an acid-base reaction. Okay, so I'll show you some examples of this. Okay, so the most common one is sodium chloride. Okay. You've got the sodium here, which is your metal, and you've got your chlorine there, which comes from hydrochloric acid. Okay, so the equation when it forms is our acid, which is hydrochloric acid, plus our base, which is sodium hydroxide. Okay, so that's our acid and our base right there. Okay, acid, our base. Okay, and what we get from that is our salt. Okay, so our salt is sodium chloride. So hopefully you can see there what we're getting is the sodium here. Alright, there's our metal bit. There's the anion bit from our acid to give us our salt. And then of course the final product we also get is water. So it doesn't actually matter what our acid and base is, we will always get a salt of some form, and in this case it happens to be sodium chloride, which we commonly call salt. Okay, but I'm going to show you, okay, a number of different things. So what I'm going to focus on firstly are a number of different acids, alright, and a number of different bases, okay, and we're going to look at what salt we actually get from this. Okay, so first off, if we go with just a simple acid like sulfuric acid, H2SO4, and our base that we're going to combine that with is going to be magnesium hydroxide. Okay, our salt that we're going to get from that is magnesium, so it's the metal part, okay, and we get the sulfur part there, sulfate, SO4, and then we're going to get water as well. If we do another one, I'm going to keep changing colours on these so you can see that it doesn't really matter the acid and the base that we have. I'm going to go with nitric acid, HNO3, and I'm going to combine that with another base. In this instance, I'm going to go with calcium oxide, okay, because that's also a base. Okay, remember metal oxides are basic. So from this, we're going to have calcium, which is the metal part, okay, and the anion part from the acid is the nitrate. So you've just got to get your formula right, okay, use that anion and cation sheet. Final one I'm going to show you is the red one here, so I'm going to go with another acid here. This time we're going to go with phosphoric acid, H3PO4, and I'm going to react that with another base. Doesn't really matter which one we choose. For this one I'm going to do some sodium hydroxide. Okay, what we're going to get there is sodium and then our phosphate, PO4. Okay, so hopefully you can see acid base gives us salt. We always get water as our other product as well, so always remember from all of these we'll get water. Okay, that comes from the base part, so the hydroxide, the oxide, the hydroxide here, and the hydrogen part of the acid, which they all have in common. but we always get a salt, alright, which is the metal part, magnesium, calcium, sodium, okay, with the part from the acid, so sulfate, nitrate, phosphate. Hopefully that helps you for acid-base reactions regardless. So that's the first thing hopefully you should do. What I'm going to look at now are ones which are pretty similar, and I'm actually going to look at acid and bicarbonate reactions. Okay, so this time what I'm going to have is an acid, okay, and I'm going to be reacting that with a carbonate or a bicarbonate. Doesn't really matter which one, we still get exactly the same products. If you don't know what a carbonate is CO3 2 minus. The only difference is a bicarbonate has a hydrogen in there. It's HCO3 with a 1 minus. So the hydrogen is taking up one of the bonding sites on an oxygen. Okay. From these, if we have an acid and a carbonate, it's actually an acid-base reaction. So as you would expect, we're going to get a salt. We're going to get water, because it's an acid-base reaction, or carbonates of bases. But because we've got carbon and oxygen there as well, we're also going to get carbon dioxide. So an acid and a carbonate or a bicarbonate gives us salt, water, and carbon dioxide gases as well. So I'll show you what I mean. I'll give you an example of one of those. So if we go with sulfuric acid, H2SO4, we react that with a bicarbonate. Let's go magnesium. I'll just go with a carbonate to begin with, so MgCO3. Okay, we are going to get, salt, exactly the same way as before. The magnesium plus the anion part from the acid, so MgSO4. We're going to get water, and we're going to get carbon dioxide gas. Okay, that's already nicely balanced. We don't need to do anything else to it, but always check once you've written it out that you balance it up to make sure everything matches. Okay, so let me show you one with a bicarbonate. Okay, let's do nitric acid, HNO3, plus a very common one, which is sodium bicarbonate. This is called bicarb soda. You'll find it in the kitchen, also called baking soda, used to make cakes rise, for this exact reason. Okay, you're going to get a salt, which is sodium nitrate, sodium plus the anion part of the acid, plus water, plus carbon dioxide. Okay. Now, the reason we use it in cakes is it releases carbon dioxide gas. That gas expands, causes the cake to rise, so it's quite useful. But any time you have a acid plus a bicarbonate or a carbonate, you get salt, water, and carbon dioxide. Next one I'm going to show you is an active metal plus an acid. So we've got acid and we've got a metal. Okay, an acid and a metal. And what I mean by active metal is if you've got something like gold or even silver, for example, they tend to be quite unreactive metals, so you need a very, very concentrated acid. We're not necessarily talking about concentrated acids here. Okay, so an acid and a metal is always going to give you, okay, a salt again, alright, but this time what we're going to get is hydrogen gas. Okay, so an acid plus a metal gives us a salt plus hydrogen gas. Let me show you some examples of that. Okay, so I'm going to have an acid and I'm going to have a metal. Okay, and we'll have a look at the salt, and we've got to remember it's always hydrogen gas. Now remember, hydrogen gas, okay, is H2, so we're always going to have that. Okay, so first acid, let's go back to nitric acid, HNO3. Let's combine that with a metal, let's say magnesium. Okay, the salt that we're going to get from this is magnesium nitrate, okay, and hydrogen gas. You would write up a balanced equation for that. Let's look at another one. Let's look at sulfuric acid plus, copper, okay, and we're going to get copper sulfate as the salt plus hydrogen gas. Okay, last one. All right, we'll go back to phosphoric acid, H3PO4. let's combine that with another metal, let's say calcium. We're going to get calcium phosphate. So make sure you can write your formulas right, and hydrogen gas. Okay, always balance up. Okay, acid metal gives us salt plus hydrogen gas. Okay, sometimes you'll see an acid written as just H+. So what does that look like? Well, let me rub this out and I'll show you. So we've got our acid plus our metal giving us our salt and hydrogen gas. Okay, so sorry, I'll just spread those out a little bit. So we've got our acid, we've got, this time we'll show it as just H+, which shows any sort of acid. Okay, we're adding that to our metal. Let's go with magnesium again, Mg. We're going to get our salt. Now we don't know what the anion part of the acid is, so all we're going to do is get the cation part of the metal, so it's Mg2+. Okay, plus we get hydrogen gas. We balance it up. We need 2 hydrogens there. Okay, and that not only balances the hydrogens, it also balances the charge. So that's how you can write it with just using an acid rather than, say, the full acid. H+ represents any acid. Okay. So the best thing that you can do is just start going through and practicing some of these. Okay, you've got to remember in the notes there's some extra ones that we're looking at, where we're looking at metal oxides. All right, so you need to be able to write equations for metal oxides plus an acid. Okay, now metal oxide, if you remember, is a basic oxide. Okay, so all this is a base plus an acid reaction. So we know this is going to give us salt plus water. Okay, you also need to be able to do metal oxides plus water when it's soluble. Okay, basic oxide, water is amphoteric. That means, amphiprotic means it can be an acid or a base. Okay, so again, it's a base and an acid. It will give you salt plus water. So it's the same process all the way through. Okay, you've just got to be able to look at the pattern and remember the basic principles of acid, base, salt plus water. Okay, if you do non-metal oxides, okay, so if we look at non-metal oxides, non-metal oxides are acidic, so quite often we'll react that with a base. Again, acid, base reaction, salt plus water. What we quite often refer to though for a base is actually just the hydroxide ion, OH-. Okay? If we substitute water in here, remember water is amphiprotic, so it can act as an acid or a base. So in this case it would be acting as a base again to react with the non-metal oxide, which is acidic. So you'll have acid plus base gives you salt plus water. It's no different. Okay? So don't let the different things fool you. Right? If you've got just H+ for an acid or OH- for a base, okay, it just means you're leaving out the end part of the acid, all right, or the starting part of the base, and it just means that your salt is going to be slightly different. Okay, so best thing to do is have a look in the section on the website under worksheets. There's a whole booklet there around chemical equations. Okay, give you lots of practice looking at the different types. Okay, hopefully this helps you. Go back, pause, have a look at just the general structures: acid, base, salt, water. Okay, acid and carbonate gives you a salt plus carbon dioxide plus water. Okay, have a look at them. Ask me if there's any more questions. Hope this helps. See you guys.